Section 5.5 is just a continuation of our max-min problems. So they're going to be the same type of problems. You're going to follow the same steps. There is just a little twist when we go and find the domain on some of these problems. So there's just a different, kind of a different case that we'll talk about here. So if you look at this example, this is the only example we're going to do. It goes right along with some of the examples we did back on 5.4. In fact, we did an example like this in 5.4, plus you had problems on your assignment that looked a lot like this. So let's follow our steps. The problem is the sum of two non-negative numbers is 30. By the way, non-negative means it has to be greater than 0. It can't be negative, so positive numbers, but it would also include 0. It says find both the numbers if the sum of twice the first plus the square of the second is a maximum. Okay, so let's start this off. Let's start out first by deciding what our variables are. So in this case, I have two numbers. So I'm going to say x is my first number, and then I'm going to say y is my second number. Okay, second step is to come up with our primary equation. Remember, the primary equation has to involve whatever you're trying to maximize or minimize. So the second sentence there says find both numbers if the sum of twice the first plus the square of the second is a maximum. So it's really that sum right there that we're trying to maximize. So that's going to be my primary equation. So I'm going to say S is my sum. So S is equal to twice the first plus the square of the second. All right. So there's my primary equation. Now notice that I have three variables there. I have S, which I want, but then I have X and Y. I need to get that down to just have one variable. So I need to either write it in terms of X or in terms of Y. To do that, that's step number 3, is we have to come up with a secondary equation so that I can substitute something in for the X or the Y. So read the problem again, figure out what our secondary equation is. The first sentence says the sum of the two non-negative numbers is 30. So right there, I can come up with a secondary equation. That means that x plus y has to equal 30. Okay, so I come back up here. I either need to solve for x and substitute it in for x, or solve for y and substitute it in for y. I think I'm going to go for x because if I substitute in for y, I'll have to square it. Seems like a teeny bit more work. So I'm going to come down here. I'm going to solve for x. So if I solve for x, I'd minus the y over, so x is equal to 30 minus y. So I'm going to come back up here, rewrite my equation. S is equal to 2 times 30 minus y plus y squared. Because I'm going to have to take the derivative, I'm just going to simplify that equation down, make it a little bit easier to work with. So distribute the 2 through 16 minus 2y plus y squared. Okay, step number 4 is the domain, and this is where this problem is a teeny bit different than the others. On the problems we did in 5.4, our domains were always open-ended. They didn't include the endpoints. But think about this problem for a second. What do we know about y? And I'm looking at y for the domain because my equation is in terms of y. So one thing we know about y is that it's non-negative. Well, if it's non-negative, it means it has to be greater than 0, but it can also be equal to 0. So y has to be greater than or equal to 0. Okay, let's see if there's, think about the biggest y could be. When I add x and y together, it has to equal 30. Well, if x is equal to 0, that's the smallest x can be a 0. So if x is 0, the biggest y could be would be 30. So the domain ends up being this, is y has to be greater than or equal to 0, but less than or equal to 30. So again, before we did the domain, it was always open-ended. So that's going to change our problem just a little bit, and you'll see that here as we go through this. Okay, but anyway, I got the domain. Y has to be greater than or equal to 0, less than or equal to 30. Okay, let's actually take the derivative and look for our max or min. In this case, we're looking for our max, I guess. We're going to do our first derivative number line test and find that. So S prime would be 60 would go away, negative 2 plus 2y. So find your critical numbers, set it equal to 0. Let's solve this. So if I add the 2 over, I end up getting y is equal to 1. Okay, place this on your number line. So I'm going to go on my number line. Now before, remember our endpoints were open-ended. Now they're going to be closed. They're going to include 0. They're going to include 30. And then I have that critical number right there at 1. Okay, let's test our interval. So try something to the left of a half. Remember, be careful. Make sure you're plugging it into the derivative when you're testing it, because we're testing whether the area, or the, excuse me, not the area, the sum, whether the sum is increasing or decreasing. So if I plug in a half, 2 times a half would be 1. Negative 2 plus 1 is a negative. So to the left of 1, the sum is decreasing. Okay, plug a number into the right of 1, so we could do like, let's do 10. I plug in 10, 2 times 10 is 20, negative 2 plus 20 is a positive. Okay, so the issue we have here is we're trying to find a maximum. 1 is not a maximum, right? To the left of 1, the sum is decreasing. To the right of 1, the sum is increasing. It's a minimum. So if it asked for a minimum, I'd be good. It'd be 1, but it's not, it's a max. So you got to think back to when we did absolute maxes or absolute mins. When you have an absolute max or min, that's what we're trying to find. What's the maximum the sum could possibly be, the absolute max? You have to take into account endpoints. So in this case, it's either got to be this endpoint when x is 0 or this endpoint when x is 30. All I'm going to do then is come back up to my original equation right here, and I'm going to plug 0 in for y and find out what I get. So s of 0. Then I'm going to plug 30 in for y and find out what I get. And whichever one's the biggest has to be my maximum. So if I plug 0 in, I'd get 0, 0, so just leave me a 60. If I plug 30 in, 2 times 30 is 60. 60 minus 60 is 0, plus 30 squared. 30 squared is 900. So my max is definitely at when y equals 30. Excuse me. So if I come back up here, it wants to know what the numbers are. That's one of my numbers. The second number is 30. I've got to find the first number. Just like before, that's when we can use this equation right here. So if I plug 30 in for y, 30 minus 30 is 0. So I would say my first number is 0, my second number is 30. If I were writing a sentence, if it asked me to, I would say, to maximize a sum of twice the first plus the square of the second, the first number has to be 0, the second number has to be 30. So what I want to point out here is the reason why this is different than all the others is before, when I looked for a max, this number right here, our critical number, always came out to be a max on 5.4. On some problems on 5.5, it won't be. So if this is not my max, then I've got to consider my endpoints. I've got to plug those numbers back in and check and see what I get back out to figure out which one would be the max. So it's a little bit different, but the steps are still the same. It's just that little bit of twist on including the endpoints if it's a closed interval. If it's not a closed interval, then you don't have to worry about that. All right. Hey, these problems, what's challenging about them is they're all a little bit different. Like they have different context, they have different variations. It makes them challenging. Try them and make sure you're getting a hold of me. If you're having, with questions or, we can work through some problems together. Make sure you contact me and let me know. Thanks, guys.